Alright, today's lesson involves adding and subtracting in order to solve inequalities. Very similar to adding and subtracting to solve equations, except for we're working with inequalities in this lesson. So your objective is to be able to solve inequalities using addition and subtraction. Alright, so first of all, how many solutions does an inequality have? So if I'm looking at something like this, like x is smaller than 3, just ask yourself, how many numbers are smaller than 3? Well, that should seem pretty obvious that it is an infinitely many amount of solutions. Because you have numbers such as 2, 1, 0, all the negatives, and then every decimal value in between there as well. So what does this look like? All the numbers are smaller than 3. So here we're not going to include 3. So we're going to be using an open dot. When it's just a less than or a greater than symbol, use an open dot. If it had the equals part, you'd use a closed dot. So I need to grab a pen. Okay, sorry about that. Alright, I'm going to go to 3. I'm going to put an open dot here at 3. And then all the numbers smaller than that, so it's going to be all these numbers over here. And that is graphing an inequality on a number line. As I mentioned before, if you see the equals part underneath, then you do want to use a closed dot to represent that as including that number. So for example here, all the numbers that are larger than or equal to -1. So I'm going to go to -1, and I'm going to use a closed dot here to show I'm including -1. And then all the numbers bigger than that, so that way. Alright, x is smaller than 4. Here we're going to use an open dot. And smaller than. Now here when the value is, or the variable's on the right hand side, I always switch it. It's easier for me to understand what it's trying to tell me to do. So I recommend always putting the variable on the left hand side, because this says all of the numbers here that are smaller than -5, versus this is saying -5 has to be larger than all unknown numbers. To me, this is just a little bit easier to make sense as to what's going on. So -5 over here, and we want all the numbers smaller than -5, so this way. Alright, and there's a few more examples for you. Alright, if you're given the graph and you have to write the inequality, same thing. You can use any variable. I'm just going to use x. Alright, so this is looking like -6.5. Alright, and our goal is just to place the inequality symbol there. So we were looking for all the numbers that are bigger than -6.5, so greater than. And here we have x, and we have a 4. I know I'm going to have the equal sign there because it's filled in. Alright, we want all the numbers that are smaller than 4. All right. Or equal to, of course. Alright, now here's the objective of the day, is to solve using addition and subtracting. Basically, some of you guys like to use a T-chart or something where you draw a line down the middle, whatever you got to do there. I'm just going to draw a line down the middle. So I have x take away 5 has to be larger than 3.5. So in order to get rid of that -5 there, I'm simply going to add 5 on both sides here. So x has to be larger than 8.5. All right, and then I can go over to the number line here, and 8.5 is right here. Larger than goes this way. It says here to check by plugging a number in to make sure that what your actual answer is correct. So if I pick a number such as 10, 10 is bigger than 8.5. If I do 10 minus 5, that's 5. 5 is larger than 3.5. Just to do a quick check to make sure what you did was actually correct mathematics. Alright, example 2, it's a decimal here. No different. Let's see. Let's draw a line down the middle. Let's get rid of this -9.2 by adding 9.2 on both sides. Okay, so p has to be smaller than or equal to 4.2. Alright, so let's say 4.2 is right about here. And we want want to fill in my dot. And smaller than. So if you want to put a little mark there saying that that's 4.2, that'd be okay, because otherwise it's kind of hard to tell. Alright, and one more on this page. I'm going to add the 1/2 on both sides. Notice here how I'm working on this side. I'm always working on the side with the variable on it, because I'm trying to get the variable isolated. Alright, so if I have -1 and I add a 1/2 to that, that's going to leave me with -1/2 or -0.5. And again, here I have the variable on the right hand side. I don't like that when it comes to graphing, so I'm going to switch that around. So my variable is on the left hand side. So all the numbers that are smaller than -1/2. So -1/2 is about here. Close dot. I'm just going to let my readers know that that is -1/2, and we're looking for all the numbers smaller than that, so let's go this way. Alright, there's a couple examples for you. Here's a word problem that kind of goes along with this. Let's say you are traveling and you need to pack a bag and check it. Max amount of pounds is 50 pounds. You can have less than that, but you can have more than that. So far you've packed 16.8 pounds. Write an inequality for how many more pounds you can add, and then graph the inequality. So I have a maximum of 50 pounds. I can have up to 50 pounds, so we're going to include the equals part. So I have some amount of weight, we'll call that a W. That's the amount that we're going to add extra, or the amount that I can add extra to the 16.8. So I have my 16.8, and I can add some unknown amount of weight to it. Alright, so we'll just subtract the 16.8 from both sides, and then we'll have our solution. Alright, so we have a 0.2, we have a 3, and a 3. Alright, so 33.2 is the max amount that I can add to what I already have. Now here on a number line, if your number line doesn't have the values, we can just get rid of this here. And let's make a new number line. Alright, so what I would do, I would go with 33, and then I'd go with 34, and then we'll say 33.2 has to be right there. Okay, so up to 33.2. Close dot to the left. So instead of making a huge number line going all the way up to 33 or 34, just focus on what you're actually graphing here. Alright, quick summary. Basically, when you are solving inequalities using adding and subtracting, you're just using the inverse operation, similar to how you'd solve equations using adding and subtracting. Basically, you're isolating the variable. Next up, we will be doing multiplication and division.